So we have two solids, right? There's the thin ring and there's the uniform cylinder. They have the same mass, they have the same radius. Not that that's actually all that important, right? And then, at this point, the kids are looking at a list of the moments of inertia. And so the question is, which one of these is going to be the harder to accelerate, right? And maybe they shouldn't look at the list, right? Maybe they should just think about the two clamps on the piece of wood or something like that. And eventually they'll be like, this one's harder to accelerate because all the mass is out at the edge, right? Okay. And then, you put the thing on the plane and you're like, okay, when it's going down the plane, is it accelerating linearly or is it accelerating rotationally? And of course, it's doing both, right? It's accelerating linearly and it's also rotating, right, if there's friction. And so, then the question is, are they going to accelerate at the same rate, right? Or even if you back up, right, if it's slid down the plane, is that easier than actually rolling down the plane, right? Of course, I guess it's harder to roll, right? Because you have to do both kinds of acceleration. And then you have them predict, which one's going to win in a race. You have to be very careful how you do the race, right? Here, I'll put the ring in front. I think it's probably the best presentation here, right? And just pull it away. And sure enough, there it is. You can see the ratio of the accelerations, and you can do, best 2 out of 3 or something like that, right? There it is. And it's easy to, if you bump it, if you don't do it carefully, right? It's easy to get the this guy can win sometimes. And it's like, oh, that wasn't supposed to happen.